This is Radhika. I am going to discuss about the power electronics. Under this, today we are going to discuss about the speed control of DC or AC motors. So, mainly today we are going to discuss about the basics or introduction of speed control of DC or AC motors, and also we are going to discuss about the factors affecting the speed control of DC motors. So, actually, what is the speed control? The speed control. It is the intentional change in the speed of the drive to a desired value for performing the specific work process. It is the intentional change in the speed of drive to a desired value of performing the specific work process. So, actually, what is the speed? So, here in this actually what is the speed control? Here the speed control means intentional change of the drive speed to a desired value for performing the specific work process. In industries as well as domestic loads need speed variations. In some applications, the speed required is very precise for position adjustments, as in robotics. Other type may needs variations or speeds in steps, uniform, etc. During the 19th century, the speed of DC motors are controlled by varying the field current, armature current, and by reducing the applied voltage to the motors. During the 19th century, the speed of DC motors are controlled by varying the field current, armature current, and by reducing the applied voltage to the motors. But by using this method, we are not able to get the exact speeds as we desired. Similarly, the speed of AC motors are also not achieved exactly by the changing the supply voltage, frequency, number of volts, etc. The motors are also not achieved exactly by changing the supply voltage, frequency, number of poles, etc. After 1950s, due to rapid development of thyristors and its handling capacities, the thyristors are using for speed control of AC and DC motors. Here we have the few advantages of thyristor control drives or motors, that are the drives are used in motors are higher accuracy, means exact desired speeds can be achieved, greater reliability, higher efficiency of operation owing to absence of moving parts and I square R losses, means copper losses, ease of maintenance, low installation cost, lower floor space is required, soft start and reduced mechanical stresses, energy saving is more, and also we have the few disadvantages of thyristor control drives. It requires harmonic filters and effective filters for reducing the harmonic content, hence it is costlier. The heat produced is more, and also we have the advantages of power electronic drives, that are high efficiency due to low loss in power semiconductor devices and owing to absence of moving parts. Higher reliability of power electronic converting system and also long life and requires less maintenance. And also it has lower installation cost, small size and hence requires less floor area, and also soft start and reduced mechanical stresses. Soft start and reduced mechanical stresses, mass production of power semiconductor devices, and hence the cost of the equipment is very low. Fast dynamic response as compared to electromechanical converting equipments, low power loss and hence more energy savings can be obtained. It is independent of the environmental condition. It can be operated on all the quadrants. It is very large range of speeds. These are the few advantages of power electronic drives, and also we have the few disadvantages of electric power electronic drives, that are the heat produced is more, it requires harmonic filters and active filters for reducing the harmonic content, hence it is costlier. It can cause noise pollution. The output power obtained from the drive is low. The output power obtained from the drive is low. Initial cost of the system is high. So here, so in this, so in this, in electric drive, the system employed for supplying mechanical energy for motion control is called drive. If electrical energy is used for driving the drive, then it is called electric drive. So here it has some history of AC motors. Speed is varied by using of changing the supply voltage. We can vary the speed using of changing the supply voltage, by changing the supply frequency, by changing the number of poles, by rheostat control method, by injecting an EMF in the rotor circuit, and by operating two motors in cascade. So, we are using these types of variations to control the speed. And also we have the few disadvantages, that are exact speeds are not possible. So really some exact speed is not possible, so that will be just more or lesser than the actual speed. And also it is more maintenance cost, and also it has the more energy loss. So the thyristor control drives. So if power electronics devices such as thyristors are used for controlling the speed, then the drive is known as thyristor control drive. Means if power electronic devices such as thyristors, we have the more than 15 thyristors, using of that thyristors we are used for controlling the speed, then the drive is known as thyristor control drive. So we have the few advantages of thyristor control drives, that are it gives the accurate speed and low installation cost, it has the high efficiency, and it has a good maintenance, and also it is very reliable. It occupies less floor area, and also it is energy saving, and also it gives the fast operation action. So here AC voltage controllers, thyristor based device. AC voltage controller is the thyristor based device and converts fixed AC voltage into variable AC voltage, and also no change in frequency. We have the few advantages of thyristors AC voltage controllers. It is the flexibility in controlling high efficiency. It is the flexibility in controlling. It has the high efficiency. It is the compact in size and has the less maintenance. The disadvantages of thyristor type A AC voltage controls. The disadvantage of thyristor type AC voltage controllers. The disadvantages are harmonics in the output voltages and interference effect. It has the interference effects, means it has the disturbances, and the harmonics in the output voltages. In output voltage waveforms, it has the few harmonics. And here factors affecting the speed of DC motor. In this, here here we have the few factors affecting the speed of DC motor. So in this equation, so here in this derivation, speed equation of DC motor, when the supply is given to motor armature, causes it continues to rotate due to motor action. When the supply is given to the motor armature, causes it continues to rotate due to motor action. The armature conductors cuts the magnetic flux and therefore EMFs are induced in them. The direction of this induced EMF is very opposite to the applied voltage. Hence, it is called back EMF. Already in previous classes, we discussed about the back EMF. So, the back EMF is the direction of induced EMFs is very opposite to the applied voltage. Hence, it is the called back EMF. In this back EMF, the magnitude of back EMF, the magnitude of back EMF is given by EB is equal to pi ZNP by 60A volts. Already we know the equation, and also from this equation the applied voltage V is equal to EB plus IARA volts. We know this equation also. Here neglecting the drop at brushes. From this equation, we can consider EB is equal to V minus IARA. Comparing these two equations, we will get pi n pi ZNP by 60A, that is equal to V minus IARA. From that equation, we got n is equal to V minus IARA by pi n pi ZP into 60A. From that, the speed n is equal to k into V minus IARA by pi RPM. In this, here k is equal to, the value k is equal to 60A by ZP is the constant value, and IA is the armature current, Ra is the armature resistance, V is the applied voltage, pi be the flux or pole in motor, A is the parallel path, Z is the number of conductors. So, this is the basic equation of speed. The speed of the DC motors depends on armature resistance, applied voltage and field flux control method. So, normally to control the speed we have the three factors that are armature resistance, applied voltage, field flux control method. From the equation of this one here, in this equation we have the n is equal to k into v minus ia Ra by pi. From this equation we are controlling the applied voltage, armature resistance and flux. So, using of these three factors we can control the speed of the DC motor: armature resistance, applied voltage and field flux control method. So, methods of speed control of DC motors. So, here methods of speed control of DC motors, we can use the by varying the armature resistance, by varying the field flux, by varying the field applied voltage, by rotor rheostat control method, by injecting an EMF in the rotor circuit, by operating two motors in cascade, by varying the armature resistance, by varying the field flux, by varying the applied voltage, by rotor rheostat control method, by injecting an EMF in the rotor circuit, by operating two motors in cascade. So, this is the first method, that is armature resistance variation method. So, we can control the speed using of armature resistance method. In this method, the variable resistance RC is the variable resistance, that is the rheostat, is connected in series with the armature winding. After applying the voltage across motor, due to voltage drop in the variable resistance, the back EMF EB is decreased, hence the speed of the motor is reduced. In this, after applying the voltage across motor, due to voltage drop in the variable resistance, the back EMF EB is decreased, hence the speed of the motor is reduced. Here in this diagram we have the motor, it is the shunt field, means it is the DC shunt motor, and also has the variable resistance, and also here the load current IL, the current will be divided as IA armature current and shunt field current ISH. So, here a variable resistance RC is connected in series with the armature resistance. By varying the voltage across the motor, a drop occurs in the series resistance. Thus, we can vary the voltage across the motor by varying the resistance, N directly proportional to V minus IA into RA plus RC, and also here N directly proportional to EB. This method is used for running below rated speeds. So, here and also we have the field flux variation. So, in this here we have the motor and the motor has the shunt resistance and rheostat variable resistor, and the load current will be divided as armature current and shunt current. So in this we know that the speed of the motor indirectly proportional to 1 by pi, already we discussed. So the flux of DC motor can be changed by varying ISH shunt current with the help of the shunt field variable resistance. The flux of DC motor can be changed by varying ISH with the help of a shunt field variable resistance. When R is increased, ISH will be decreased, causes the pi decreases. Consequently, the motor runs above the normal speed. When R is increased, ISH shunt current will be decreased, causes the flux decreases. Consequently, the motor runs above the normal speed. If the resistance decreases, the speed will be decreased. So here, in this here n directly proportional to 1 by pi, the flux of DC motor can be varied by varying the shunt current with the help of shunt field variable resistance. And also when R is increased with ISH, shunt current will decreased and pi gets decreased. Then the motor runs above the normal speed. If resistance decreases, the speed will decrease. This method is used to run the motor above the rated speed. In this method is mainly used to run the machine above its rated speed. And also third one is the varying the applied voltage. So already we have know the n directly proportional to V minus Ia Ra by pi. Here in this circuit diagram it has the motor and is the shunt field, and also the load current will be divided as Ia armature current and shunt current. So in this method the input voltage to the motor varied because the speed of the DC motor is directly proportional to the applied voltage. Hence, by varying the applied voltage, the speed of the motor can be controlled. In this is the equation of n directly proportional to V minus Ia Ra by pi. Here in this, the speed is directly proportional to the applied voltage. If applied voltage is increased, the speed increased. If applied voltage is decreased, the speed is decreased. So here means here the speed will be depends on only varying of the applied voltage. So now we can watch the one YouTube video about the speed control of DC motors.
Hello friends, in previous videos we have studied what is DC motor. In this video we are going to study the speed control of DC motor. Basically a DC motor is designed to operate at the fixed speed or constant speed, but some applications require the speed of the motor to be reduced or the speed of the motor to be increased. So depending upon the application, the control of the speed of DC motor is very important. Hence, in this video, we are going to study how to control the speed of DC motor. Before learning the speed control of DC motor, let us derive the equation for the speed of DC motor. We know that the equation for back EMF is given by E is equal to Pn phi z divided by 60A. Here, P is nothing but number of poles, N is the speed, then phi is the flux, Z is the number of conductors and A is the number of parallel path. This equation is similar to the generated EMF of DC machine. Now, in this equation, if we rearrange the terms to find the equation for speed, we get the equation as N is equal to E multiplied by 60A divided by P phi Z. Equation number 2. Now, in DC machine, the number of poles Z, that is total number of conductors, and A, that is total number of parallel path, is always constant. So let us assume them as the constant, which is denoted by K. Hence we can again write this equation as, let K is equal to 60A divided by P into Z. Substituting this K in equation 2, we get N is equal to E multiplied by K divided by phi. If we take the reciprocal of this K, which is constant, then that value will also be constant. Hence, we can again rearrange this equation as N is equal to E divided by K into phi. If we see from this equation, we can say that the speed of the DC motor depends upon generated EMF E and the flux phi. If we consider the initial and final values for the speed, flux and EMF E, then let us assume that let N1 equal to initial value of speed, E1 is equal to initial value of EMF, phi1 is equal to initial value of flux, N2 is equal to final value of speed, E2 is equal to final value of EMF, phi2 is equal to final value of flux. Hence, using these values, we can again modify the equation as, for initial values, equation 4 can be written as N1 is equal to E1 divided by K into phi1. Let it be equation number 5. Similarly, for the final values, the equation can be written as N2 is equal to E2 divided by K into phi2. Equation number 6. Now, if we take the ratio of equation 6 to equation 5, we get N2 by N1 is equal to E2 divided by K into phi2 divided by E1 divided by K into phi1. K will get cancelled, so we can write this equation as N2 by N1 is equal to E2 divided by phi2 divided by E1 divided by phi1. This type of equation will give us the relation between initial and final values. This equation is very important while solving the numericals. Now, let us study what is speed regulation of DC motor. Speed regulation is nothing but difference between full load speed and no load speed expressed in terms of full load speed. Hence, the equation for the speed regulation can be written as speed regulation is equal to N no load, that is NNL, minus NFL, that is full load speed, in the ratio of N full load. Now, if we want to find the percentage speed regulation, the same equation can be modified as percentage speed regulation is given by NNL minus NFL divided by NFL multiplied by 100, where NNL is the no load speed, NFL is the full load speed, again NFL is your full load speed. The DC motor, which has almost constant speed, has a very good value of speed regulation. As we have already studied the characteristics of DC shunt motor and DC series motor, we have seen that in case of DC shunt motor, the speed is almost constant. Hence, the speed regulation of DC shunt motor is very good. Now, let us see how to control the speed of DC motor. As we have already derived the equation for speed previously, we can write the equation for speed as N is equal to E divided by K into phi. But we know what is the equation for E. Hence, we can write the equation for E as E is equal to V minus IaRa. Now, if we substitute equation 2 in equation 1, we can modify equation 1 as N is equal to V minus IaRa divided by K into phi. This equation is the basic equation for the speed control of DC motor. If we see this equation carefully, we can say that the speed of motor basically depends upon armature current, flux and the supply voltage. Here we can say if we control the voltage, if we control the armature current and if we control the flux, we can control the speed of DC motor. So we can write that speed of DC motor basically depends upon, first is armature resistance denoted by Ra, second is voltage which is denoted by V, and third is flux which is denoted by phi. So depending upon these three parameters, there are the three basic methods of speed control of DC motor. These methods can be written as follows. First method is armature resistance control. In this method, we are going to control the resistance of armature. Then second is field flux control. In this method, we are going to control the flux. Then third is armature voltage control, which is also called as Ward-Leonard method. This method we are going to control the armature voltage. Hence, these are the four basic methods of speed control of DC motor. Thank you friends for watching this video. Stay tuned with Ekeeda and do subscribe.
So this is the YouTube lesson for speed control of DC motors. Now we have the summary. In this, we learn today's class about the speed control of DC motors and various methods of speed control of DC motors, and also it has few advantages and few disadvantages. Here in this, we have the advantages of thyristor control drives, that are the drives are higher accuracy, exact desired speeds can be achieved, it is the greater flexibility and greater reliability, higher efficiency of operation owing to absence of moving parts and I square R losses, is the ease of maintenance, low installation cost, lower floor space is required, it's also soft start and reduced mechanical stresses, energy saving is more. The disadvantages of thyristor control drives are it requires harmonic filters and effective filters for reducing the harmonic content, hence it is costlier, the heat produced is more. And also we have the few other advantages of electronic drives, that are high efficiency due to low loss in power semiconductor devices and owing to absence of moving parts, higher reliability of the power electronic converting system, long life and requires less maintenance. It has the lower installation cost, small size and hence requires less floor area, soft start and reduced mechanical stresses, mass production of power semiconductor devices, and hence the cost of the equipment is very low, fast dynamic response as compared to electromechanical converting equipments, low power losses, and hence more energy savings can be obtained. It is independent of the environment condition. It can be operated on all the quadrants. It is very large range of speeds. And also these have the few disadvantages of electric electronic drives, that are the heat produced is more, it requires harmonic filters and active filters for reducing the harmonic content, hence it is costlier, it can cause noise pollution, the output power obtained from the drive is low, the initial cost of the system is high. So these are the few advantages and few disadvantages of electronic drives. So these points, all points are we learnt today class, and here we have the few quiz questions here. The question is, which method is not used to control the DC motor? Flux control method, armature resistance method, applied voltage method, and changing the frequency method. Answer is D, changing the frequency. And also here, which method is used for vary the speed of DC motor above the rated speed? So in this, the above rated speed means all varying the three means armature resistance, and so the varying armature resistance will be worked below rated speed, and the flux method is used this method use run the machines above the speed. So above the speed means it works the varying the field flux method. Field flux method is the used for above speed. And also we have the few frequently asked questions that are: state the factors affecting the speed of the DC motor, and also it has the explain various methods of speed control of DC methods. So today we learnt about the speed control of DC methods. Next in class we are going to discuss about the speed control of DC motors using choppers and shunt motors. Thank you.